Hello, I'm Islam, Cloud Support Engineer here at the AWS office in Dublin. Today, I'll show you how to handle malformed JSON files when querying data in Amazon Athena. Let's get started. We will cover some of the issues you may encounter when dealing with JSON data on Amazon Athena, how to investigate the errors, and how to fix them. After logging into the AWS Management Console, navigate to the Amazon Athena console. I already created a table that queries a malformed JSON file, so let's run a select query. As you can see, the query failed with the exception hive cursor error row is not a valid JSON object. To avoid the query failure when there is a malformed JSON, the third property ignore malformed JSON should be added to the table. For that, we can either recreate the table from the Athena console or update the table metadata from the AWS Glue console. Let's navigate to the AWS Glue console. Click on Tables, choose the table JSON Malformed, and then select Edit Table. In the 30 parameters section, let's set Ignore Malformed JSON to True. Navigate back to the Athena console and run the select query again. As you can see, the query is now successful, and the corrupted rows show as empty. To identify the files with malformed JSON, I can use the following query. Here's another way to identify the rows and file names that correspond to an invalid JSON. First, let's create a table with a delimiter that is not present in the input file. I can use the DDL example provided in the Knowledge Center article. Now, let's run this query to return the file name, row details, and the Amazon Simple Store service path for the JSON rows that are invalid. You might encounter JSON exception when using Hive JSON Serde or OpenX JSON Serde with JSON text in pretty print format. Let's see an example. I have the following data stored on Amazon S3. As you can see, it's in pretty print format. Let's return to Athena and create a table to query that file. I'm using the following DDL query. Let's now run a select query. As you can see, the query results in the error hive cursor error row is not a valid JSON object. This error occurs because the Serde that was used doesn't correspond to the format of the data. The OpenX JSON Serde expects that each JSON document is on a single line. To resolve the issue, we can recreate the table using Athena DDL query and then use the IonHive Serde as it can parse the JSON in pretty print format. Another option is to update the table and replace the OpenX JSON Serde by IonHive Serde. We can update the table metadata from the AWS Glue console. I'll open the AWS Glue console and edit the table. As we did previously, let's choose the table first and then choose Edit Table under Actions. We must update input format, output format, and serialization library as following. Return to the Athena console and let's run the select query again. The query is now successful. Let's now see the last scenario covered in this video. I have the following JSON file that I want to query. Let's return to the Athena console and create a table using the following command. Let me try to query the table. The query returns the error hive cursor error row is not a valid JSON object, JSON exception, duplicate key. This error occurs because the source data has two keys that are the same when they are in lowercase. To fix the issue, let's update the table to make it use case-sensitive key names. Again, let's update the table from the AWS Glue console. Let's first set the property case insensitive to false to be able to use case-sensitive key names. Then, I can use the mapping property to map the key username with uppercase to a different colon name. For example, I can map it to username with underscore. Return to the Athena console and let's run the select query again. You can see from the results that the key username in uppercase was mapped to the colon username with underscore, and the query is now successful. And now you know how to handle malformed JSON files when querying data in Amazon Athena. Thanks for watching, and happy cloud computing from all of us here at AWS.